Today on NerdOut, Hydrozoa. Welcome back to NerdOut, the show where we take a look at Cardano and we break it down but not dumb it down. Today we have a special guest. He's been on the show before. I'd like to welcome back to the stage George Flerovsky of the Hydrozoa team. So welcome, George.
Thanks, Andrew. Glad to be here. It's been a while, I think. Perhaps our last session was around this time last year.
Yeah,
so a lot has happened since then.
And we wanted to bring you back, talk about Hydrozoa, what's been happening, what's new, what's old, where the project's at. So yeah, just give us a little background so people remember what is Hydrozoa, and then maybe give us a quick status update.
Absolutely. So Hydrozoa is a state channel protocol. And the basic idea is that a group of people get together and they put their funds into collective control on layer one. So for example, Cardano, right? And this means that they are collectively in charge of ensuring that their dealings with each other follow a certain set of commonly agreed on rules, right? But then once they do that, they are able to interact with each other on a virtual ledger that is private to them, right? And in that ledger, each person is able to submit transactions individually. They don't need to coordinate together. All that matters is that, when Alice submits a transaction, she broadcasts it to the rest of the peers. All of them double check that it makes sense relative to what's currently happening in the ledger. And then once they all kind of sign off that it fits with the ledger rules, the transaction gets confirmed immediately. This is the key point, right? This is the selling point essentially of Hydrozoa and Hydra and all of the state channel solutions out there. Once the group of people reaches quorum, in terms of they all agree that this transaction fits the rules that they are operating this ledger on, the transaction is confirmed.
Right. You're not waiting for a block or anything like that. It's done.
And it's not probabilistic like it is on Cardano layer one, where, you can wait for your transaction to show up in a block that is buried under, say, another 8 blocks or something. And that gives you pretty good assurance that the transaction won't get rolled back if the change switches to another fork, but there's no guarantees. The only real guarantee you have is that immutability threshold, which takes about 12 hours to achieve on average, again. So it's all very probabilistic on L1. Which is not to say that L1 is terrible, right? I should mention, with L1, the deeper your transaction is in the blocks, the exponentially smaller the probability of rollback becomes, right? So it's actually not too bad on L1, but still, people have to be prudent and have to wait a certain number of blocks on L1 to go through before they can consider their transaction to be accepted. Whereas on a layer 2, like Hydrozoa and Hydra, that happens much faster because you just need to gather the signatures of the peers. Right? So that's the basic idea. Now, the trickiness with this is, this works really well when everybody gets along, everybody's responsive, and everybody's following the protocol. But what if one person stops participating? What do we do then? Right? That's the key question. And this is where a lot of the complication sort of arises in all of these protocols. Traditionally, with Bitcoin Lightning, that was the first place where this idea took off. What they would do is they would say, all right, every time we agree on a new virtual state between us, first of all, in Bitcoin Lightning, there's only 2 people ever, right, in a particular instance, right? And what they're doing is they are signing a new transaction that kind of overrides the previous transaction, right? And does it in such a way that if any party submits an outdated transaction, not the most recent one, there's like a waiting period, and the other party can come in and basically penalize the transgressor by taking everything, right? Essentially, that's how Bitcoin Lightning enforces this, which is very punitive, right? And also, you have to be on your toes because it's very time sensitive in terms of you have to respond quickly.
Yeah, both parties have to be online when a Lightning transaction goes through. From my
that's the case for all of these things, right? This is this is a separate concern, right? What you were talking about, everybody has to stay online. That's just for the regular operation, right? Not in terms of like if consensus falls apart. For consensus to stay, operating, everybody needs to be responsive to each other. That's the only way this is going to work. What I'm talking about is that when consensus breaks down, there's like a dispute period, and you have to be aware that it's happening because you need to be able to enforce your interests, right? Because at that point, everybody is for themselves in a sense, right? So Hydra was an evolution of this, where they said, okay, well, first of all, we want to be able to have more than 2 people inside of a head. And there's actually a very good reason for this, right? I don't know if the original authors of the Hydra paper necessarily realized this or analyzed this too much in terms of why, to N rather than 2, right? But since then, I've seen some interesting papers that kind of have analyzed what some of the benefits are. And before getting into Hydrozoa, I think we should kind of describe what these benefits are in the first place. So one of the weaknesses of the Bitcoin Lightning Network, or one of the constraints, is that liquidity is very constrained for doing transactions between heads and even between heads. And the reason for that is that if you can only have 2-party heads, if you enter into a Lightning channel with me, right, your funds are exclusively dedicated to interactions with me, and you can't reuse them for any interactions with anybody else. So this fragments your liquidity across the channels that you're participating in, right? And it means that the same thing applies for me, right? In order for me to allow you to receive money through me, I have to dedicate that money to a channel that is exclusive between me and you, right? So that fragments me too, right?
Right, and then what Bitcoin does is it sets up people in the middle so that, like, if I need to send money to you, but we're not connected, then I can kind of bounce that through all the channels, and then everybody takes a tiny little slice of that.
Exactly, but the problem is with the Bitcoin Lightning that if you're trying to chart a path through this like hop, using these hops between the different channels, right, from Alice to Bob, everybody along the path needs to have sufficient capacity to make this payment go through, right? And furthermore, the way that Bitcoin Lightning works, and there's this whole gossip thing, no one actually knows what the actual capacity is of a channel at the moment when you attempt to make a payment, because there's lots of payments going back and forth and the channel might get disbalanced and so on, right? So at the moment when you attempt to make the payment, it might fail on the third hop because somebody else already went in that direction, right? And reduced the capacity of those available to you, which is why under the hood with Bitcoin Lightning, when you make a payment, the Bitcoin Lightning node is going to make a bunch of attempts through different paths and keep renegotiating paths, and the first one that goes through is the one that is going to say that.
No, I think what a lot of people end up doing is it kind of centralizes Bitcoin Lightning because everybody tries to connect to like the big liquidity providers. Like, oh, I'm going to open my channel with Kraken, and so then you kind of know that there's at least a path to get to wherever you need to go. But
exactly. It's a very centralizing influence.
They become a big hub on that network.
Right. Whereas with a multi-party head, the nice thing is that your liquidity is less fragmented, right? If I enter into a head with Andrew, Pi, and I don't know who else, Phil, right? And each of you brings 200 ADA, right? I'm able to receive the sum of 600 ADA, right, through this channel, right? While personally, I'm only putting up my own 200 ADA, right? So I'm able to kind of combine the liquidity of all of my partners in the head in terms of the receiving end, and my 200 ADA is able to go through paths that go through either Andrew or Phil or Pi, right, in any combination. So there's a lot more flexibility, and indeed there's a theoretical paper from the end of 2024 that kind of analyzes this, right, and they're still kind of more Bitcoin Lightning centric in there. The authors of that paper, but they said that, hey, what if we took Lightning and we just introduced some proportion of the network, we made them into multi-party heads? What would improve in terms of, would fees go down? Would success probability of a payment go up? and so on and so forth. They kind of, unfortunately, I think they focused more on the fees aspect, which I think is interesting, but less interesting than the success probability and generally like some of those other things that, in my opinion, would have been more like higher priority for me anyway, for analysis. But still, they show that there are tangible benefits from doing that.
Yeah,
right.
Let's get back to Hydrozoa and
right. So
what has changed in the last year?
Well, okay, let me explain. So we've gone through Bitcoin Lightning, we've gone through Hydra. What does Hydrozoa do different, right? So the tricky part with Hydrozoa is that it uses Pluto scripts, and it doesn't fully leverage the deterministic nature of Cardano, right? Which is not a problem. Hydra is a fully it's a fairly functional protocol and everything. And now that it has incremental commits and decommits, some of the early sort of wishes that I had when I was coming up with Hydrozoa have partially been fulfilled with Hydra. Although I should note that with Hydra, I believe still incremental commits and decommits are kind of handled sequentially, so you can only have one commit going into the head at a time, and you can't have anything else be queued up or anything before that one is resolved. The same thing with stuff coming out, right? So that still is a little bit of a bottleneck, right? The main innovation of Hydrozoa is that we want to leverage to the extent possible, to the maximum extent possible, the determinism of Cardano, which means that our peers, if we're clever, should be able to just chug along and keep confirming stuff, right? Without ever really having to check back and wait for stuff to get confirmed on L1. That's the key benefit of Hydrozoa. It wasn't fully realized in the version that existed, I think, a year ago or maybe before then. But now with the new improvements, it is, right? So Hydrozoa's consensus now basically never has to wait for L1 to catch up, right? And the way we do that is we make sure that anything that we're trying to spend from L1, so deposits coming in, we wait for them to settle on L1 before we make the decision of like absorb or not, or don't absorb the deposit, right?
Okay.
And this means that at the time,
so many blocks, or how do you make that determination?
we use a time-based thing. And it's configurable, so it's just a kind of a protocol parameter of Hydrozoa itself. But suppose that your group of people believes that it's good enough to wait for like 20 minutes for a deposit to settle on chain, right? Such that you're unlikely to encounter problems if you attempt to if you rely on, you come up with you decide to absorb it and it's part of your like block, and you've moved on and have relied on it having been absorbed. And then you come back and you realize that, oh, actually this deposit never existed because it never settled in the first place. And somehow the depositor managed to get another transaction in that contradicted it, therefore makes that deposit impossible, right? And therefore, it turned out it didn't exist at all, right? Which is not to say that Hydrozoa can't recover from such a scenario. It's just that in the normal course of operations, we want to mitigate those things happening, which is why we impose that wait time on deposits. They just have to sit a little bit on L1 before we try to absorb them, into the L2. But besides that, everything else happens at the speed at which the peers are able to agree on what they want to do, right?
Cool.
And so every round of consensus, the peers are agreeing on a sequence of events, right? Like a sequence of L2 transactions and a sequence of deposits that they are queuing up for the future to be absorbed if they exist after maturity, right? And it's just a sequence where they say, okay, valid, invalid, right, and so on of the sequence, right?
Okay.
The sequence is set by the leader, and the leader rotates across the peers, right?
Okay.
This is another key distinction between Hydrozoa and Hydra. So, for example, in Hydra, when a user sends a transaction to one of the peers, the peer immediately applies it to their local state, then broadcasts the transaction to the other peers, and all the other peers also apply to their local state. And then they have to do some sort of reconciliation in case,
Right.
transaction A arrived before transaction B for some people and transaction B arrived before transaction A for other people, right? In Hydrozoa, this doesn't happen. We don't evaluate the transaction until, first of all, the peer is the one who evaluates it in the order in which the transactions arrive at that peer. And then he's basically broadcasting to all the other peers the order in which he's evaluated the transactions. And all of the other Hydrozoa peers are supposed to replicate it the exact same order.
Okay.
And that way we never have disagreements.
So there is kind of a leadership aspect inside Hydrozoa, whereas with Hydra there is not. They're all.
Yeah, this is something that we've borrowed from the Raft protocol.
Okay.
Right. So Raft works this way, the way that I just described for Hydrozoa. In Raft, there basically is a leader. The leader doesn't change unless there's connectivity problems or the leader goes down or something, right? And he's just there kind of publishing just block after block, right, of events that he's processed, and everybody else is replicating, everybody else is signing off that, yep, what you sent us makes sense in terms of it's all valid the way you said it would be, right? In Hydrozoa, we still want this rotation, right, because we want it to be symmetric in the sense that everybody gets a turn being leader, right, so that no one can monopolize the sequencing of events, right, which, as you can imagine, right, if one person always monopolizes the sequencing of events, you might get into trouble with them being able to play around with the ordering of things, right? Whereas with Hydrozoa, since everybody gets a turn and the turns rotate really quickly, it's a non-issue, right? Mm-hmm. And in fact, even it like you could say that maybe if Alice is the current leader, she might do something funny, right? And before Bob's turn comes around, right? And so Bob is kind of concerned about this. Well, the thing is, Bob's turn is going to come around really quickly. So if Bob is planning to submit a sensitive order that he is afraid might get sandwich attack or some sort of MEV shenanigans, he can just wait until it's his turn and submit it then. Mm-hmm. That way he can guarantee that nobody is able to mess with him, right? And just the fact that Bob can do this means that there's no point for Alice to even attempt as a general practice to even be prepared to do funny stuff, because she knows that anything that she could actually earn any MEV on would probably be protected by the ability of the corresponding leader to just wait their turn to be leader, right? And therefore nobody really has any incentive to engage in any kind of MEV, despite the fact that each leader, when it's their turn, has the exclusive right to set the sequence. Mm-hmm. Does that make sense?
Yeah.
So, that's kind of a disorganized path through explaining Hydrozoa, right? But the general gist is that Hydrozoa is able to go at full speed, never has to wait for L1, is able to absorb a bunch of deposits in parallel, basically as they come in. The only constraint on them is really that they have to wait on L1 for that period of time for them to settle before we can risk trying to absorb them, right? And on the flip side, Hydrozoa was able to handle as many withdrawals as you want, right? Mm-hmm. And in fact, we make it very easy.
So what about people joining and leaving the head? So like you have head participants, is there the ability for like external people to participate in the Hydrozoa head without actually being a head operator?
Yeah.
Is that something you could do?
So this is something that you can do, but you have to be very careful about, right? Mm-hmm. So, and I think you mentioned there's two sort of separate things that you mentioned in there. So first of all, can you have people enter and leave as participants of the head? Right. And the second question is, can you have non-participants of the head submit stuff and have the head control that? Those are kind of two separate things. Okay. I'll address the first one first. So theoretically, in principle, all you need to do to change the membership of participants in the head is just to have the existing members sign off saying that, yep, we're allowing this person to now have collective control with us over what happens in this head, right? Mm-hmm. So if everybody signs off on like a governance action, essentially, right? That's all you really need, right? And indeed, that's kind of how we haven't implemented this yet in Hydrozoa, because we've been kind of prioritizing other things a little bit and trying to kind of get the core features more like ready and integrated and kind of demoable and stuff, right? But I don't like. I know how this is supposed to work, like in terms of the membership change, and it's just on the to-do list, right? Slightly on a second tier kind of backlog, but it's there. And the idea is you have the peers sign a governance action, essentially, just multi-sign a statement that says, okay, the new group is going to be this, right? And then we just enter that into consensus. We submit it in, and then we just make the corresponding changes, right? And the head keeps chugging along, right? And same thing goes for removing a member, right? So if all the existing members agree, right, then this person can leave and no longer have any responsibilities towards the group, right? And similarly for key rotation. So for example, if a member wants to change the key with which he is participating in consensus, right, it's another governance action. You just say that, okay, we all agree that we're going to allow this guy to use this new key, right? So that's the idea there.
Yeah. So the second part of my question was, how does a non-participant in the head participate? Because, eventually we want to use this technology for things like instant payments at vendors or vending machines or, remittances. How does somebody with just a mobile wallet where they're not going to run a whole Hydrozoa head on their phone, how do they participate and still get instant finality and all the benefits that Hydrozoa brings?
Absolutely. So this is something where that Hydrozoa itself doesn't answer, because it's sort of the scope of Hydrozoa is limited to, okay, how do we ensure consensus between the peers? But this is what Gummy Worm is for. And I've been having a lot of very exciting conversations with Pi about Gummy Worm over the past, half a year or so. I think, we sat down for like 3 hours or something, or a couple hours or something at the pool at Caesar's Palace during Rare Evo, and we just chatted about this stuff, geeked out for that whole time, and lost track of time. But the idea that's the essence, that's the purpose of Gummy Worm. So in order to allow people without veto power, essentially, right? So like the people in the head, like the normal participants in the Hydrozoa head, each one of them has veto power over what happens in the head. And this ensures that nothing can happen with their funds because they have veto, right? External participants don't have the right of veto unless they want to become participants, right? Or like, consensus participants. So we need to somehow provide them with some guarantees, right, that their funds won't get stolen. And so essentially the way that Gummy Worm approaches this is it says, we're going to expand consensus to include not just the core participants of the head, but a certain quorum of external ratifiers, right? So whatever happens in the head essentially gets leaked out to a surrounding layer of ratifiers, right? I think Gummy Worm calls them the coil operators, right? And we say that, okay, some majority, right, or some quorum of these coil operators who are independent of this group of people, or supposedly, right, should double check their work and ratify what these guys agree to. And this should prevent the head operators from being able to do anything, funny just on their own. They would have to go out there and somehow collude with all the coil operators. But if the coil operators are like anonymous and so on, right, like you can kind of guarantee it. It's sort of a step in the direction back towards L1, right, on that spectrum between pure multi-sig consensus and like, an Ouroboros gossip style consensus, right? This is like if you take a multi-sig consensus and introduce a slight bit of gossip around it, right, which is, by the way, configurable, right? Like the network and the threshold can be changed depending on how sensitive it is, right, in terms of the funds going through this head. And this, the hope is that this provides enough safety for certain use cases, right, for users to be able to interact with this, right? That's kind of the Gummy Worm approach. And Hydrozoa has been designed with this in mind. So I don't see there being any significant obstacles, right? And in fact, I think only a slight kind of expansion of features or not so much expansion, even more of an abstraction. modularization of the features in Hydrozoa would be required to accommodate something like this. And this is something that Pi and I have been talking about for a while now, and definitely is something that I would like to explore.
Very cool.
Right.
Well, I work at several companies, and I'm sure we'll be talking in the future about solving these fast payments issues for the normies out there. So
absolutely,
that's where we want to go. Is all of this tech has to enter the real world at some point where
I
can tap my phone and just do the payments.
Absolutely. I should mention, I can't quite talk too much about it right now, but I can tease that Pi and I we have something in the works that may be demoable eventually. So keep tuned for that. Although I can't say much more.
Sounds good. Anything else you want to discuss about Hydrozoa, or maybe where you're going? Win mainnet. I've got to ask that for my audience.
Yeah. So let's talk project status. So last time we spoke, let's say it was January of 2025. Hydrozoa was a white paper, not a single line of code written, and I had admitted as much back then. Right. Since then, we've written a bunch of lines of code. We've implemented the majority of the we've implemented the protocol. Right now, we're sort of integrating the last pieces of the protocol together and kind of assembling them and testing them all together and stuff like that, and kind of applying the layer with which you're going to interact with this thing. So we were kind of focused on the core mechanisms and stuff. We didn't spend, I guess, maybe as much time in terms of like, how you're supposed to, send HTTP requests and stuff to it, right? But that's kind of the stuff that we're doing right now. It's not complicated. It's fairly straightforward, very standard stuff, right? Because the non-standard stuff is what we've already dealt with, right? So that's where we are right now. And I think, I am planning to present a demo of this at Builders Fest. So at the end of March. So
I will see you there.
Is it going to be production, mainnet ready at that point? Well, one can hope, but I think it's going to be more of a demo. But it's not going to be a fake demo. I don't mean that. Oh yeah, just ignore all of this. This is all pretend, right? Like we're actually going to be creating, transactions and submitting them and stuff, and that kind of thing. So it's going to be real. But besides that. One of the things, we're now kind of shifting gears into more use case territory, right? We actually want to build use cases using Hydrozoa as the middleware that drives them, right? Mm-hmm. So this is the sort of these are the sorts of engagements that we're looking at. I think starting a month or two from now, we're going to be looking at maybe onboarding people like that. So definitely, if you or your viewers want to try that out around that time frame, reach out and we can.
Yeah, no, I've already got 2 major use cases, so we'll be talking offline.
For sure, yeah. And for the future, one of the things that I would love to explore, actually, and I've been thinking about this for a while. I think I sketched it on a napkin back at Rare Evo. No, not even Rare Evo. The Builder Fest of last year. In Vietnam. Yeah. I have a napkin sketch that I unfortunately didn't save to be framed later. But I have this idea where, what if the L2 ledger doesn't have to be UTXO, right? I mean, in Cardano, we've gotten used to creating applications and then having to fit them into the UTXO model, right? And essentially describing or implementing your business logic as a bunch of UTXO interactions. Mm-hmm. Well, Hydrozoa doesn't care what the L2 ledger is, right? It's UTXO for, kind of if you want UTXO and you just want to do a bunch of stuff that is still like Cardano style and reuse a lot of the stuff that you were doing on Cardano, but in the L2 ledger. But if it's not like a legacy app, or I don't mean legacy, I mean one that has already been developed for Cardano before and already works within the UTXO model. If it's another use case that's just coming in fresh and has never been on Cardano before, right. But wants to benefit from some of the security guarantees that Hydrozoa provides, plus if Hydrozoa consensus breaks down, some of the, being able to kind of recover the funds on L1, where, you have the L1 consensus guarantees, right?
Mhm.
Well, why not just have a domain-specific ledger, right? So I'll make this more concrete. If you have like a supply tracking situation, so I think Blazar Labs from Moldova have been wanting to do like with wineries. They wanted to keep track of inventories and also like of the wine bottles, and keep track of like where the wine bottles come from and stuff like that, right? And how they were made and so on, right? Do they need to represent all of that as UTXOs? No, they would probably prefer to have some domain-specific representation. And from our end, all we need to know is how to translate that on demand whenever they want to push stuff out to L1 into that representation. So that's an idea that I really want to explore with different use cases out there. And I think it might lower the barrier for adoption of blockchain for a lot of the use cases out there, right? Where they get to reuse a lot of their existing processes, and then we just need a translation layer when needed for the interactions that they're actually doing to L1.
Yeah, that makes sense.
But they can do most of their interactions off chain. So, yeah.
Very cool stuff. Yeah. So any final thoughts you want to share, or anything we should be looking for, announcements, et cetera, et cetera?
I would say that I'm probably going to keep quiet, mostly quiet until Builderfest.
Okay.
It is a little bit head down, last mile type of thing, right? It's funny. I have felt a little bit like the chef who keeps saying, just 5 more minutes, right? And has been saying this for an hour now, right? But I promise you, the soup is going to be good. So, so when it eventually comes out, but you will see kind of something tangible from me at Builderfest. So I think that's the next kind of checkpoint for us.
Okay. Well, I will talk to you at Builderfest, and I'll probably share with you my at least 2 projects that are potential use cases for you to get on that path to real world adoption for this tech.
All right. Thank you very much, Andrew.
Okay. Yeah. Thanks for joining us. And with that, nerd out.